Let us consider a Cartesian coordinate system. Let P be a point. Here we have x-axis and y-axis. How to denote this point P? It has coordinates x and y. What does this mean? We need to move x units on x-axis and then y units on y-axis to reach this point. In polar coordinate system, the same point P is represented as r, theta. What is r here? R is a line from origin to P. R is the length of this line. This is r. R is the length of the line from origin to P. And what is theta? Theta is the angle subtended by this line r. Let us call this as theta. Now in Cartesian coordinate system, a curve is represented as y is equal to f of x. In polar coordinate system, curve is represented as r is equal to f of theta. Let us consider this curve. In this curve, a tangent is drawn. PT is the tangent to this curve, and OP is the radius vector. Let us denote this radius vector as r. PT is the tangent at point P on this curve, and this phi is the angle between the radius vector and the tangent. Psi is the angle subtended by the tangent, and theta is the angle subtended by this radius vector. Let us make this construction. Let us this curve is r is equal to f of theta, and the point P has coordinates r, theta. The angle between the radius vector r and the tangent PT is phi. If the angle between the radius vector r and the tangent is phi, then tan of phi is equal to r into d theta by dr. We need to prove this statement. Suppose we are given a curve, a polar curve r is equal to f of theta. The angle between the radius vector and the tangent is phi, then tan phi is equal to r into d theta by dr. This is what we are supposed to prove. Tan of the angle phi is equal to r into d theta by dr. That is what we are supposed to prove. Tan phi is equal to r into d theta by dr. To prove this, let us make this construction. Let us consider another point on the curve f of theta. Let us call this point as Q. Coordinates of P are r and theta. Let the coordinates of Q be r plus delta r and theta plus delta theta. Let us join these 2 points P and Q. We have chord PQ, and let us also join origin with Q. It is OQ. Let us drop a perpendicular from point P to this line OQ. PM is the perpendicular. This is delta theta, and let us call this angle MQP as alpha. Now let us consider this triangle OMP. In this triangle, what is sine of delta theta? Sine of an angle is equal to opposite by hypotenuse. Here the opposite side is MP and the hypotenuse is R. So it is MP divided by R. You can write this as MP equal to R into sine of delta theta. In the same triangle OMP, what is cosine of delta theta? Cosine of an angle is equal to adjacent by hypotenuse, OM divided by R. Therefore OM equal to R into cosine of delta theta. what is MQ equal to? This is MQ. We have dropped a perpendicular from this point P where we have drawn the tangent to this curve. From this point on to this line OQ, this PM. What is MQ equal to? We can write MQ as OQ minus OM. Now what is OQ equal to? See, the coordinates of this point P on this curve are r comma theta. What does that mean? This line OP is of length r and the angle subtended by this line OP is theta. Similarly, if you consider this line OQ, what is the length of this line? If you look at the coordinates of point Q, it is r plus delta r comma theta plus delta theta. So what is the length of this line OQ? In case of P, it is r. In case of Q, it would be r plus delta r. So OQ is equal to r plus delta r minus, what is the length of OM? We have OM here. OM equal to r cos of delta theta. This can be written as delta r plus r into 1 minus cosine of delta theta. We are taking r as common factor here. We know that 1 minus cos theta can be written as 2 sine squared theta by 2. So here we can write this as delta r plus r into 2 times sine squared delta theta by 2. Here, if this point Q tends to P, delta theta tends to 0 and this angle alpha tends to phi. So what is tan phi equal to? Tan phi is equal to limit of tan, let us say alpha. This is the angle alpha. What is tan alpha equal to? Let me write tan alpha here. Tan alpha is equal to tan of an angle is equal to opposite by adjacent. That is nothing but MP divided by MQ. We know what is MP. MP is here r sin theta. This is equal to r sin delta theta whole thing divided by delta r plus 2r into sine squared delta theta by 2. So what is tan phi equal to? As Q tends to P, this angle alpha becomes phi and delta theta tends to 0. So tan phi is equal to limit of tan alpha. As Q tends to P, this alpha becomes phi as Q tends to P. This is nothing but limit of tan alpha, which is nothing but r into sine delta theta whole thing divided by delta r plus 2r into sine squared delta theta divided by 2 as delta theta tends to 0. Now this can be written as, this is equal to limit of r into sine delta theta divided by delta theta divided by delta r divided by delta theta. We are dividing both numerator and denominator by delta theta, plus 2r into sine delta theta into sine delta theta, sine delta theta by 2 into sine delta theta by 2 whole thing divided by delta theta. We can bring this 2 here. Delta theta by 2 is nothing but 2 into, so we can bring the 2 here. Where is this 2? It is nothing but delta r by delta theta plus r into sine delta theta by 2 into sine delta theta by 2 divided by delta theta by 2. If you apply this limit of sine theta by theta as theta tends to 0 is equal to 1 here, this would become that is nothing but, let me write tan phi again, tan phi equal to r into 1 divided by dr by d theta plus r into sine of delta theta is tending to 0. Forgot to write this. Delta theta tends to 0. Delta theta tends to 0, so sine 0 is equal to 0 into sine of delta theta by 2 whole thing divided by delta theta by 2 is nothing but 1. This vanishes. Tan phi becomes r into, if you bring this to numerator, d theta by dr. This is what we are supposed to prove. If you have a curve r equal to f of theta and the angle between the radius vector and the tangent is phi, then tan phi is equal to r into d theta by dr. Now suppose you have two curves like this, C1 and C2, and if you draw a tangent T1 to C1 and T2 to C2, what is the angle between these two tangents? Angle between these two curves is nothing but angle between these two tangents. Now we have the formula to find out the angle phi 1, phi 2, tan phi 1, tan phi 2. The angle between these two tangents is nothing but phi 2 minus phi 1. If phi 2 is greater than phi 1, then this should come first, otherwise this phi 1 should come first. So we can write this as mod of phi 2 minus phi 1. That is the angle between two curves C1 and C2. When they ask you to find out the angle between two curves, it is actually the angle between the tangents drawn for these two curves C1 and C2. So phi 2 is actually the angle between the radius vector, and this is the radius vector, and the tangent T2, and phi 1 is angle between the radius vector and tangent T1. When I subtract phi 1 from phi 2, that gives me this angle, which is angle between these two tangents. That is nothing but angle between curve C1 and C2. So it is given by this phi 2 minus phi 1 or phi 1 minus phi 2.